5.2, Using Intercepts. In this section 5.2, you're going to be looking at the Y-intercept and the X intercept. The Y-intercept is the y-coordinate of the point where the graph intersects the y-axis. The x-coordinate of this point is always going to be 0. So if I were to take a coordinate plane, the y-intercept is the point that follows or falls on the y-axis. The x-intercept is the x-coordinate of the point where the graph intersects the x-axis. And when you're trying to solve finding the x-intercept, the y-coordinate of this point is always going to be 0. So if I have a graph, coordinate grid, and I have a line that point that goes through the x-axis would be my x-intercept. Let's do some examples here where we're going to be finding the x and the y-intercept. So for finding the x-intercept for A here, we're going to look along the x-axis, and where does this linear line fall on the x-axis? Well, it falls right here at the point -2. So my x-intercept is going to be -2. My y-intercept is going to be the point that falls along my y-axis, which is right here. Starting at 0, we go 1, 2, 3, so that is going to be the value 3. So my x-intercept, -2. My y-intercept is 3. Looking at example B, we have this equation, and it's not necessarily a graphed line, but we have this equation, and working with this equation, we need to find the x-intercept and the y-intercept. Now to find the x-intercept, you're going to plug 0 in for y, and to find the y-intercept, you're going to plug 0 in for x. Okay, so let's do this so you can see what it looks like. So we're first going to find the x-intercept. So I'm going to use the equation -3x. Now, plus, to find the x-intercept, we're plugging 0 in for y. So I'll plug in 0 equals 30. Another way to write this would be -3x equals 30. Divide -3 to each side. So my x-intercept, x is going to equal 30 divided by -3 is going to give me -10. Now let's find my y-intercept. Now to find my y-intercept, I'm going to plug in 0 for the x. So I have 0 plus 5y equals 30. Another way to think of this is just 5y equals 30. Divide 5 to each side. So my y-intercept, or my y, equals 30 divided by 5 is 6. So my answer for B let me erase this here so I can write it down. So my final answer is my x-intercept is going to equal -10, and my y-intercept is going to be 6. So if you were to graph a linear line based on this equation and finding the x and the y-intercept, you're going to have a point going along the x-axis at -10 and a point falling at the y-axis at 6. Let's look at C here. We have 4x plus 2y equals 16. And here again we need to find our x and y-intercept. Let's find our x-intercept first. So we have 4x. Remember, my y is going to be equal to 0, so I can just equal this to 16. 4x equals 16. Divide 4 to the left and to the right side. So my x-intercept is going to equal 4. Now to find my y-intercept, I get my x equal to 0, so I have left 2y equals 16. Divide 2 to each side. My y-intercept, 16 divided by 2, is going to give me 8. So that is my x and my y-intercept for C. Means I'm going to have a point falling along the x-axis at 4 and a point falling along the y-axis at 8 when I graph a linear line. The next example, it says the school store sells pens for $2 and notebooks for $3. The equation 2x plus 3y equals 60 describes the number of pens x and notebooks y that you can buy for $60. They want us to graph the function. Well, we can graph this by using by finding the x-intercept and the y-intercept like I did in the previous example. So I can write my equation here that 2x plus 3y equals 60. Let's find my x-intercept first. So I'm going to have my y be 0, so I have 2x equals 60. Divide 2 to each side. So my x-intercept, 60 divided by 2, is going to give me 30. Now let's find my y-intercept. I'd plug in 0 for x, so what I'm left with is 3y equals 60. Divide 3 to each side. So my y-intercept for A, 60 divided by 3 is 20. So what that means is I'm going to have, when I graph points on this coordinate plane, my x is going to fall along 30. My y, there's going to be a point at 20. So I can set this graph up based on tens, so I can have here 10, 20, 30. So my 30, my x-axis will be right here. And then going up the y-axis, we can count by tens as well. 10, oops, 10, 20. So here's 20, here's 30. And I would draw a line to connect those 2 points, and that line represents the function 2x plus 3y equals 60 by finding my x-intercepts and my y-intercepts. What does each intercept represent? Well, what this is representing is that my x-intercept, here I'll show you here, my x-intercept is representing the pens that can be purchased if no notebooks are purchased. My y-intercept is representing notebooks that can be purchased if no pens are purchased. So that's what each intercept is representing in this graph. Let's do our last example. It says use the intercepts to graph the line described by the equation. So here we have our equation. Negative 3x plus 4y equals negative 12. We need to find my x-intercept and we need to find my y-intercept. So we're going to use this equation to help me solve that. Remember, to find my x-intercept, you're plugging 0 in for y. So 4 times 0 would give me 0. So to solve, I have negative 3y equals negative 12. Divide negative 3 to each side. Actually, this is 3x, not 3y, sorry. Divide negative 3 to each side, so x is going to equal negative 12 divided by negative 3 gives me positive 4. So my x-intercept is 4. To find my y-intercept, plugging in 0 for x, so we have 4y equals negative 12. Divide 4 to each side to find y. So my y-intercept is going to equal negative 3, because negative 12 divided by positive 4 gives me negative 3. So now let's graph. Along my x-axis, where's my point going to fall? At 4. So we have 1, 2, 3, 4. I'll put my point. Along my y-axis, it's at negative 3. 1, 2, 3. Plot my point. Oops. Now I'm going to connect these 2 points. And that line right there represents the equation of negative 3x plus 4y equals negative 12. So you can graph these by just finding your x-intercept and your y-intercept.